So welcome to our speech today about can motor pumps for natural refrigerants. Don't worry, it's the same topic, just in English. My name is Adrian Schäfer and I'm responsible as Product and Application Manager for the refrigeration pumps at Hermetic. And today we would like to have a closer look first into the common natural refrigerants, their properties, their specific considerations. And in a second step, we would like to clarify why using Kent motor pumps, what are the differences to other centrifugal pump technologies, what are the benefits also for the other technologies. And last but not least, going into the most common pump failure reason, cavitation, and how we can avoid it. At this slide, I just brought you a market research for industrial refrigeration systems worldwide. You can see that ammonia is and also should be in the future the most popular, most important refrigerant in this market. But it also shows that CO2 is more and more common, with the biggest growth expected with 7% per year. In third place, HFCs. There's no growth expected because of all the regulations. For example, also the F-gas regulations here in Europe. It tries to control the CO2 emissions and to reduce the global warming effects. Ammonia itself, as I said, the most important one in the industrial refrigeration systems. It's highly efficient. Theoretically higher than or more efficient than propane, for example. There's a low boiling point, and also a big advantage is the low pressure design which is needed. So we are talking normally about 16 bars pressure. But disadvantage is it's toxic. It has a really intensive smell. For example, for leakages, there could be negative effects for goods and also for humans. It has a chemical reaction with copper and copper alloys, and these 2 points make it more expensive for the refrigeration installations itself. CO2 as a second important refrigerant. It has also low global warming potential. Actually it's a reference value for the GBP, so it's 1. And in contrast to ammonia, it's not hazardous for products, for humans in big volumes, but normally not. Disadvantages: CO2 is called a high pressure. It's called a high pressure refrigerant. So we need also to design our installations with higher pressures. For operation, but also for standstill pressures if needed. If we don't work with pressure relief waves, for example, for transcritical systems, sometimes we would like to skip it. So we are talking about up to 90 or 100 bars. And there it's also quite expensive to have all the components with these high pressure, with these high pressures. And one also big disadvantage is that the operating is sometimes or often near to the tribble or critical point. So we have the fact that, for example, for maintenance, dry ice can occur, and this must be avoided at all. Different kind of applications in the cooling industry, also for different refrigerants, for example, water glycol in the train industry for the cooling of inverters. You have ammonia, for example, for the classic warehouses or for also fishing industry. And CO2 is more and more coming for the supermarkets, or you have combinations, ammonia, CO2 cascade systems, where you can find also in the food industry, for example, for sportive facilities. So why using Kent motor pumps? We will follow up now. I would like to focus today on centrifugal pumps. So we have 3 different kind of technologies, centrifugal pumps with double mechanical seals. Second, we have magnetic coupled pumps. And last but not least, Kent motor pumps. Here you can see a typical centrifugal pump with double mechanical seals. You've the motor part coupled with the pump shaft, which is laid into two bearings, one plain bearing, one rolling bearing. And at the front, the hydraulic part with the suction and discharge nozzle, and on the pump shaft, the impeller. Second, the magnetic coupled pumps. As an alternative, on the right side, you can see the motor unit coupled with the hydraulic system. The hydraulic system is separated into two different parts. The primary, which is connected to the motor shaft directly, and it's turning same direction, same speed as the motor itself. And you've connected with, or not connected, but it's separated with a permanent magnets. You have the secondary part with the impeller in front, and also here you have the same direction of rotation. Last, Kent motor pumps, you can see that there's no separation of hydraulic and motor part. The motor is integrated into the pump. You can see here the motor, its stator package is outside the liquid, and the rotor package is fixed on the hollow shaft. So the liquid is coming from the front, going through the impellers along the can itself. The can is separating the stator and rotor package, and the lubrication, the fluid is lubricating the plain bearings at the back side and also on the front side, and taking the heat out of the motor parts through the hollow shaft back to the front of the pump. What are the differences between these three technologies? I mean, pump with double mechanical seals is a huge selection possible. You have low initial costs normally. You have also the lowest heat input because you have no heat input in it. And disadvantages, you have high risk of leakages, higher maintenance costs because you have to do it regularly. Magnetic coupled pumps, it's having an external motor, which is cheap. So it's from the price side in the middle of the three technologies. You have less maintenance itself, but you also have an heat input in your liquid. The heat input in the liquid you have also for Kent motor pumps. And you have the highest cost for these three initially. And you have some losses. It's around 5 to 7% through the can. But you have also really important benefits. For example, you have the maximum safety itself. You have the lowest lifetime cycle costs. So if you're not just focusing on 2 or 3 years, but on 10 or 20 years, you have the best technologies here. It's really compact, it's easy to install, and it's also resource saving because of the long lifetime. Going into safety, you can see that especially if you have high risk applications, if you have high temperatures or really high pressures, then Kent motor pumps are the best solution for it. On the other side, if you don't have it, sometimes it's better to have the other technologies, for example, magnetic drive pumps or double mechanical seals. For example, for water or water glycol, it's often just used the other pump technologies. Also, for the mean time between failures, you can see that we are normally calculating for Kent motor pumps for 8 to 12 years. The maintenance costs are higher than the other ones, but if you're seeing it on a long term, then it's the most efficient way, even if you take into account the higher initial costs of this technology. So from hermetic side, we have also, additionally to these advantages, we have other points to consider. We have the highest experience in it in the Kent motor pump technology. We can easy and fast select through our pump selection tool. We have a short delivery time, emergency stock. If you have any emergency, that's possible to do it within a really short term. We have a large pump portfolio, not only standard, but also engineered to order ones. It's suitable for all refrigerants. We also have for explosion protection, best in price and performance, and also a global support network. Coming to cavitation, to the last point, it's the most common pump failure itself. And I just want to give you some hints how to avoid it. But in the first step, what is cavitation? Cavitation is the partial evaporation of liquid in a system through which it flows. A cavity is bubbled, filled with vapor, and is created when the static pressure in its flows drops locally to the saturation pressure of the medium due to increased flow speeds. So that some liquid evaporates, so the vapor itself implodes. You can see the direction it goes from the first picture, where you can't find any cavitation itself in the impeller. Second, it's getting to raise, but you can't see it on the QH curve. Third picture, you can see it also on your QH curve until it's totally collapsed. And in the fourth picture, you can see here. How can you determine it? Increased noise will be the first point. Then you will have some increased vibration. Afterwards, you can sometimes or often see a drop in delivery head and volume flow. Then there can be an axial thrust in it, and also the increased power consumption and a temperature increase in the liquid can be a hint, especially because of the dry running of the blind bearings. So if the vapor is collecting the liquid can't lubricate the blind bearings, and it's getting dry, and the motor will be damaged. To avoid cavitation, there are different precautions and rules. You can see some of it here. It's just a hint, and I just want to go into details into some points of it. The most important one is that the NPSH-A of the plant side is always bigger than the NPSH required from the pump, NPSH-R. And you can see in the optimum, the two curves are crossing, and there it's your operating point, and you will have still some safety buffer. We are talking normally about 0.5 meters as safety buffer. Also avoid shifting, could come to cavitation if you shift. There's several ways to control also the minimum flow, for example, flow control waves or Q-min orifices. With both ways, you control the minimum flow. With a control wave, you are more flexible. With a Q-min, you have a better degassing because you have a degassing line back to the separator. Depends what you need. Also for the installation of the separator, the suction line to the pump, there are different points to consider. For example, avoiding swirls or bubbles, also particles in the suction line. It's crucial for the pump and comes to cavitation afterwards. Also, one big point is to select the right pump. So if you want to try our selection tool, you can just go on our website under refrigeration and then pump design. Give it a try. You can also come to our booth. We have the possibility to just try it in a test case. That's it. Thank you very much for your attention. If you have questions, just let me know afterwards or come to our booth. Thank you very much.